Hi guys, I'm the Jacobian Dev, and today we'll be going through how to create columns in Revit using a CAD import. I've gone ahead and imported a CAD model with a two-dimensional column layout. We can query some of the layers in the import. As we can see, the columns seem to be in different layers. In the Jacobian Dev tab, I'll launch the CAD Columns plugin. The first combo box allows the user to select which layer the columns need to be added to. The second is to specify the column type to be added. I'll click Create to add the columns. Next, I'll change the layer and column type. I'll then click Create to add more columns. To get started, I'll head to Visual Studio where I've already got a CAD Columns plugin set up. If you're not sure how to set this up, I've added a link in the description for the first video in the channel on how to create a plugin in Revit. You can also have a look at the Adding Windows Form video on how to add a simple Windows form. Alright, I'll start by adding a label. So under the Toolbox tab, I'll select Label, and under the Label's properties, I'll change the label text to Select Layer. Next, I'll add a combo box for the CAD layer names. And under the combo box properties, I'll change the name to combo layer. Next, I'll copy both the label and combo box below. I'll then change the copied label's text to select column type. Under the copied combo box's properties, I'll change name to combo column type. Lastly, I'll add a button to create the columns. And under the button's properties, I'll change the button name to btn create and the button text to create. I'll then double click on the form to access the form's load method. Before adding the code, I'll navigate to AutoCAD to take a look at the CAD columns. I'll select one of the columns and view its properties. We can see that the column outline is a continuous polyline. Next, I'll navigate to Revit to see how we could access the column polylines in the CAD file. To do that, I'll select the CAD import and open the Revit lookup tool found in the Add-ins tab. I'll snoop the current selection. Next, I'll snoop the geometry. I'll then snoop the geometry element, which returns the geometry instance. I'll then click on the Get Instance Geometry method, which provides a list of all the geometry elements. Here we can find the column polylines. By clicking on the graphic style ID, we can get the graphic style category. With the graphic style category, we can then access the CAD polylines layer name. Alright, back in Visual Studio, I'll start by getting the CAD import. I'll declare an iList of type element ID named CAD imports. This iList of type element ID will be a new filtered element collector, passing the document as a parameter. The collector will be of class with the import instance as the type declaration. I'll get all elements which are not element types. I'll then return the element IDs. Next, I'll declare an iList of type string named layer names. I'll then check if the CAD imports list has any items. If so, I'll declare a new import instance named import, which calls the document's getElement method, passing the ID of the CAD import as a parameter. Next, I'll declare a new geometry element named GeoElla, which calls the import's getGeometry method, passing new options as a parameter. Next, I'll iterate through all the geometry objects in GeoEdit. I'll then check if the geometry object is a geometry instance. If true, I'll declare a new geometry instance, GeoInst, which will be the geometry object as a geometry instance. I'll then declare a new geometry element, GeoElement, which will call GeoInst getInstanceGeometry method. If the geometry element is not null, I'll iterate through all the geometry objects in the geometry element. I'll check if the geometry object is a polyline. If true, I'll declare a new graphic style named gstyle, which calls the document's getElement method, which requires the object's graphic style ID as a parameter. Next, I'll declare a new string named layer, which will get the layer name by getting the graphic style category name. I'll then add the name to the layer names list. Next, I'll declare a new global variable named plines, which is an ilist of type polyline. I'll then add the geometry objects as a polyline to the plines list. I'll then set the combo layer combo box data source to the layer names list. I'll return distinct elements so there are no duplicates, and I'll get the list. Next, to get all the columns in the project, I'll declare a new ilist named columns, which will be a new filtered element collector passing the document as a parameter. The collector will be of category, built-in category, columns. I'll get all the element types, and then I'll return the elements. I'll then declare a new ilist of type string named column types. So this will hold all the column types. Next, I'll iterate through the columns list and add the element's name to the column types list. I'll then set the column type combo box data source to the column types list. If there are no CAD imports, I'll display an import error task dialog stating that the CAD import can't be found. I'll then set the dialog result to OK and close the form. Back in the CAD columns form, I'll double-click on the Create button to access the button's click method. First, I'll declare a new string variable named selectedLayer, which will grab the layer combo box's selected item string value. Next, I'll iterate through the plines list. I'll then declare a new graphic style named gstyle, which calls the document's getElement method, which requires the polyline's graphic style ID as a parameter. I'll then declare a new string named layer, which will get the layer name by getting the graphic style category name. I'll check if the layer is equal to the selected layer. If true, I'll declare a new variable named poutline, which calls the polyline's getOutline method. Next, I'll declare a new XYZ point named first P, which is poutline's maximum point. I'll then declare second P, which is poutline's minimum point. To get the column insertion point, I'll declare a new XYZ method, which returns a XYZ point named midpoint, which requires a double for X1 and X2, a double for Y1 and Y2, and a double for Z1 and Z2. I'll declare a XYZ variable named midpoint, which adds the two X values, the two Y values, and the two Z values and divides them by 2. I'll then return the midpoint. In AutoCAD, we can see a schematic diagram of how to get the column insertion point. And back in Visual Studio, I'll declare a new XYZ variable named line mid, which we'll call the midpoint method. I'll pass the first P and second P X values. I'll then pass the Y values. And lastly, I'll pass the Z values as parameters. Next, to get all the columns in the project, I'll declare a new iList named columns, which will be a new filtered element collector. Pass in the document as a parameter. The collector will be of category, built-in category, columns. I'll get all the element types and return the elements. To get all the levels, I'll declare a new iList named levels, which will be a new filtered element collector, passing the document as a parameter. The collector will be of class, with the level as a type declaration. I'll then cast the levels to a list. I'll declare a new level instance named col_level. Next, I'll iterate through the levels list. I'll then check if the level name is equal to level 0. If true, I'll set the col_level equal to the level. Next, I'll declare a new family symbol instance named fs. I'll then declare a string variable named selected column type, which will grab the column type combo box selected item string value. I'll then iterate through the columns list, and if the element's name is equal to the selected column type, I'll equate fs to the element as a family symbol. Next, using the transaction T, I'll declare a new transaction, passing the document as the first parameter, and the transaction name, create columns, as the second. I'll start the transaction. I'll then declare a try-catch statement. I'll check if the family symbol is active. If not, I'll activate the family symbol. I'll then add the Autodesk Revit structure reference. And proceed to create a new family instance. I'll pass the line midpoint as the first parameter, the family symbol as the second, the col_level as the third, and the structural type as non-structural as the fourth parameter. I'll then catch any exceptions and display them on a task dialog should there be any. I'll commit the transaction. I'll then set the dialog result to OK and proceed to close the form. Once that's done, I'll go ahead and run the plugin. I'll select Always Load to load the plugin. I'll open the CAD columns project where I've already imported the CAD columns DWG file. In the Jacobian Dev tab, I'll launch the plugin. I'll change the column type and proceed to create the columns. I'll add more columns on the column B layer, and as you can see, the columns have been successfully added to the project. That should be it for this video. Please like, share, and subscribe.